What if the biggest weather story of 2026 is not a single storm, but a band of warm Pacific water quietly moves heat, rain, drought, and disaster risk around the planet? The question is not whether El Nino exists. The question is how far one strong event could reach. From space, it can look almost harmless, just color on a heat map, a warmer stain near the equator, stretching across the tropical Pacific. But if that warmth grows and if the atmosphere responds, the signal can begin to travel, rain belts can shift, storm tracks can bend. Some regions may face heavier flooding, while others watch drought tighten around rivers, farms, and reservoirs. Heat can linger where people expected relief. Crops can be stressed by seasons that no longer behave the way they usually do. That is why 2026 has become a strange point of focus. Recent high-view videos have framed the question in dramatic terms: is a super El Nino coming? But the sharper question is not whether a headline can sound alarming. It is what a strong 2026 El Nino could actually change if it develops. Here is the line we have to keep clear from the beginning. El Nino is real. It is a known climate pattern, and strong events have influenced global weather before. But a long-range climate signal is not the same as a fixed weather prediction. It does not tell us the exact storm, the exact city, or the exact week. It changes the odds. It loads the atmosphere in certain directions. So this is not a declaration of disaster. It is an investigation into why one ocean pattern could reshape global weather, why the idea is spreading now, why uncertainty may be the most important part of the story. To understand the risk, we have to strip away the dramatic language and look at the machine underneath it. El Nino is not a monster storm forming in the ocean. It is a recurring climate pattern centered in the tropical Pacific, where surface waters in the central eastern part of the basin become warmer than usual. That warming can disturb the usual balance between ocean, wind, rain, and air pressure. In a more typical Pacific setup, steady trade winds blow across the equator from east to west. Those winds push warm surface water toward the western Pacific, allowing a pool of heat to build on that side of the ocean. Near the coast of South America, cooler water can rise from below in a process called upwelling. This helps keep the eastern tropical Pacific relatively cooler, while the warmest water and some of the strongest tropical thunderstorm activity remain farther west. El Nino begins to change that arrangement. When the trade winds weaken, the warm water that was piled toward the western Pacific can spread back eastward. The cooler upwelling near South America may be reduced. The zone of tropical clouds and thunderstorms can shift with the heat, and because those thunderstorms release energy into the atmosphere, the effect does not stay neatly over the ocean. This is where the story becomes powerful, but also easy to exaggerate. The fact is the basic mechanism. Warmer central and eastern Pacific waters can alter winds, rainfall, and pressure patterns. The theory is how feedbacks between the ocean and atmosphere may strengthen or sustain the event. Warmer surface water can help change winds, and changed winds can allow more warm water to remain in place. But the speculation is whether 2026 will produce a strong event, an extreme event, or something much weaker than the online conversation suggests. That distinction matters. El Nino does not cause every flood, drought, heat wave, or storm that happens during an El Nino year. Each event interacts with the season, with regional geography, with other ocean patterns, and with the background climate already in place. Two El Ninos can share the same name and still leave very different fingerprints on the world. So the responsible question is not whether El Nino is real. It is. The question is what kind of event could develop, how strong it might become, and where it may shift the odds. The strange part is that El Nino is not a storm, and yet it can influence storms. Once warm water shifts east, El Nino stops being only an ocean story. It becomes an atmosphere story. The extra heat and moisture over the tropical Pacific can change where towering thunderstorms form, and those storms act like engines. They push air upward, disturb pressure patterns, and help bend the paths that winds take around the planet. Scientists often call these long-distance links teleconnections. The word sounds technical, but the idea is simple. The atmosphere is connected. A pressure change in one place can nudge the jet stream in another. A band of tropical rain can help move a storm track. A warmer patch of ocean can tilt the odds toward one season being wetter, drier, hotter, or more unsettled somewhere far away. This is the part that makes El Nino feel mysterious. It is not a hurricane crossing an ocean. It is not a wall of water moving toward land. It is a rearrangement of heat, clouds, winds, and pressure. And because those pieces are part of one global system, the signal can travel without looking like a single moving object. But this is also where the story can become exaggerated. El Nino does not send the same weather everywhere. It redistributes risk. In some places, a strong event may raise the chance of heavy rainfall. In others, it may increase drought stress. Some regions may face hotter conditions. Some may see wildfire conditions become more favorable if dryness, heat, and wind line up. Agriculture can feel the pressure through changes in rainfall timing, soil moisture, heat during growing seasons, or uncertainty around planting and harvest windows. Tropical cyclone behavior can also be affected, depending on the ocean basin and the season. The important word is chance. El Nino is not a master switch for the entire atmosphere. It does not guarantee a flood, a failed crop, a heat wave, or a quiet storm season. Local outcomes depend on geography, the month of the year, existing ocean temperatures, land conditions, and other climate patterns happening at the same time. A strong El Nino can push the dice, but it does not control every roll. That is the fact layer. El Nino can influence global circulation. The theory layer is how a strong event, if it develops in 2026, could amplify some of those links, make certain hazards more likely in certain regions. The speculation layer is any claim that already knows exactly which city will flood, which harvest will fail, or which record will fall. That level of certainty is not responsible this far ahead, so imagine the sequence as a chain. First, a Pacific heat map changes color. Then arrows spread outward toward continents. Then the possible consequences appear in fragments: dry riverbeds, flooded streets, heat shimmering above pavement, cloud bands curling across satellite images. None of those images is the whole story by itself. Together, they show why one ocean pattern can matter far beyond the ocean. But if El Nino is already known, why is 2026 being treated online like a bigger mystery than usual? The answer is not that a single forecast has settled the future. It is not that the Pacific has already delivered a final verdict. The reason is more modern and in some ways more revealing. Recent high-view videos in the research package show that the idea of a 2026 El Nino has broken through online, especially under dramatic titles like "A Super El Nino is coming in 2026" and "A Super El Nino triggered history's deadliest disaster." Those titles do something powerful. They turn a slow, complicated climate pattern into a simple question. Is something huge coming? But that is also where the story can become misleading. Audience interest is not the same thing as scientific confirmation. A viral title can point toward a real concern, but it cannot prove that the atmosphere and ocean are already locked into a future event. This is why 2026 has to be treated carefully. The keyword demand behind the topic appears thin, so this is not a case where a massive search trend alone explains the attention. It looks more like a breakout video market signal, where viewers are responding to uncertainty, fear, memory, and the visual power of Pacific heat maps. The fact is that El Nino is a real climate pattern with real global influence. Strong events in the past have helped shift rainfall, temperature, storm tracks, drought risk, and heat stress in different parts of the world. The theory is that if a strong event were to develop around 2026, it could interact with a warmer background climate, regional vulnerabilities in ways that make certain hazards more likely. The speculation is the leap from could to will, from risk to certainty, from a possible strong event to the most powerful, deadliest, or worst outcome imaginable. That leap is where the story has to slow down. The serious question is not whether a scary title can be written. It is what would actually have to happen in the Pacific for 2026 to matter on a global scale. Trade winds would need to weaken in a meaningful and sustained way. Warm water would need to shift and persist across key parts of the tropical Pacific. The atmosphere would need to respond, not just the ocean surface. Rainfall patterns would need to reorganize, and the signal would need to survive the noise of normal weather chaos. Even then, the result would not be one identical disaster everywhere. It would be a rearrangement of odds. Some regions could become more vulnerable to flooding, others could face drier conditions. Some places might see hotter extremes, while others experience changes that are weaker, delayed, or masked by local weather patterns. That is the gap between viral certainty and climate uncertainty. Online, a headline can arrive fully formed, as if the future has already happened. In the climate system, signals emerge slowly, unevenly, and sometimes disappear before they become anything historic. This does not mean the subject is empty hype. It means the evidence matters more than the label. If 2026 becomes consequential, it will not be because the internet named it early. It will be because the ocean and atmosphere begin to align in a way that changes the probabilities people actually live with. The internet is asking whether 2026 will be extreme. The better question is what signs would separate a real warning from a viral weather story. This is where the phrase super El Nino becomes a trap. It sounds precise, it sounds like a category, like a storm warning with a fixed meaning and a clock already ticking. But in public conversation, it is often used more loosely, as a dramatic label for an unusually strong El Nino. Unless someone defines exactly what they mean, and unless that definition is backed by evidence, the phrase can turn uncertainty into certainty before the atmosphere has finished answering. A strong El Nino is a real possibility in the world of climate patterns. A guaranteed super El Nino in 2026 is a much stronger claim, and a claim that 2026 will become the most powerful or deadliest event is speculation, not established fact. The fact is that El Nino can influence rainfall, temperature, pressure patterns, and storm behavior across parts of the world. It can shift odds, it can load the dice, it can make certain seasons more vulnerable in certain regions. The theory is that if an event becomes strong, and if it overlaps with warm oceans, stressed water systems, fragile food supply chains, or intense regional weather patterns, some hazards could be amplified. That is a serious possibility to investigate, but the speculation begins when a viral headline starts treating one possible future as if it has already happened. This is why disaster comparisons need to be handled carefully. Past El Nino events can teach us that climate patterns matter. They show that a change in the tropical Pacific can be linked with floods in one place, drought in another, heat stress somewhere else, and a cascade of pressure on farms, reservoirs, power grids, and emergency services. History is useful because it reveals the kinds of systems that can become exposed, but history is not a script that the future is forced to follow. One event does not guarantee the shape of the next one. One disaster does not prove that another disaster will be worse, and one frightening pattern on a map does not automatically become a global catastrophe. That is why a title like The Most Powerful El Nino in Recorded History is Forming in the Pacific Ocean works so well online. It compresses a complex climate question into a single dramatic image. It gives the audience a clean villain, a countdown, and a promise of escalation. But the real world is less cinematic and in some ways more unsettling. The danger may not arrive as one obvious apocalypse headline. It may arrive as a series of quieter changes in probability. A water manager sees the odds of shortage shift. A farmer watches seasonal rain become less dependable. An energy grid faces heat demand at the wrong moment. A coastal city prepares for heavy rain while another region prepares for dry weather and fire risk. Emergency planners do not need certainty to be concerned. They need enough evidence to know that the odds may be moving. So the question is not whether every dramatic claim about 2026 should be believed. It is whether the Pacific is beginning to line up with conditions that deserve attention. Even a non-record El Nino can matter if it arrives at the wrong time in the wrong background climate. with enough vulnerable systems already under pressure. And that brings us back to the central mystery. A strong El Nino, if it develops, would not rewrite every forecast map at once. It would work more subtly by shifting the background conditions that weather systems move through. Heat may pool in different places, rainfall zones may lean toward different regions, storm tracks may bend in ways that favor wet extremes in some areas and dry stress in others. And because people do not experience climate as an average, the consequences would depend on timing, strength, geography, and vulnerability. That is the key to the whole story. El Nino is not a switch that turns disaster on. It is a climate pattern that can load the atmosphere in certain directions. The fact is that warming in the central and eastern tropical Pacific can influence winds, pressure, rainfall, and circulation. The theory is that a strong event could amplify some hazards, especially when it interacts with an already warm planet and fragile regional systems. The speculation is any claim that 2026 is already guaranteed to become a record-breaking, world-changing catastrophe. So what should we watch next? Watch the Pacific itself, not one warm patch on one map, but whether warming becomes sustained and organized across the tropical ocean. A brief signal can fade. A persistent signal can become harder to ignore. Watch the trade winds. El Nino is not just about water temperature. It is about the ocean and atmosphere reinforcing each other. If the normal easterly winds weaken for long enough, warm water can spread eastward. Thunderstorms can shift. The pattern can begin feeding back on itself. Watch official climate updates and seasonal outlooks, not because any single update can tell the entire future, but because the responsible picture comes from tracking how the evidence changes over time. A forecast is strongest when the ocean, the atmosphere, and the seasonal timing begin pointing in the same direction. And watch regional advisories. A global climate pattern does not mean the same thing everywhere. A farmer watching rainfall risk, a water manager watching reservoirs, a city preparing for heat, an emergency planner watching flood potential may all care about El Nino for different reasons. This is why uncertainty matters. It is not a weakness in the story. It is the story. Uncertainty does not mean nothing will happen. It means the future is still a range of possibilities, and the responsible response is not panic. It is attention, probability, and preparation. The Pacific can look distant from almost everywhere, but the atmosphere has no walls. Circulation, pressure, moisture, and heat connect regions that seem unrelated on a map. That is how one ocean pattern can become a global weather signal, even while local outcomes remain uneven and imperfectly predictable. The viral version of this story asks for certainty now. The better version asks for evidence next. If the signals fade, the story changes. If they strengthen, the world may need to take 2026 more seriously. So stay with the evidence as it develops. Compare dramatic claims carefully. And remember that the most important warning may not arrive as a single shocking headline, but as a pattern slowly becoming clear across the Pacific.